Welcome back to my channel, Future EEs. Sagutan natin ngayon ang iba pang problems sa Test 1 ng 1001 Solved Problems in Electrical Engineering. Pero bago ang lahat, don't forget to hit like and subscribe sa aking channel and hit the notification bell para sa mga susunod pang videos. Before we start, let us recall ang mga formulas ng resistance na makakatulong sa atin sagutan ang mga problems. So, ang pinaka-main formula natin ng resistance ay R is equals to resistivity or specific resistance multiply sa length over A. Meron pa tayong dalawang formula and ipapakita ko sa inyo ngayon kung paano na-derive yun. So, alam natin na ang formula ng volume ay area times length. I-solve natin yung area in terms of volume and length. Area will become V over L. Ito yung formula natin in terms of A. Tapos, i-solve din natin siya in terms of A and B naman, hahanapin natin yung length. So, length will be equal to V over A. So, since ito yung main formula natin, i-delegate natin siya as 1. So, substitute A to 1, we will have R is equals to specific resistance times length over A, and then specific resistance times length over V over L, or equals also sa specific resistance times length multiply sa length over V. So, kakaroon tayo ngayon ng specific resistance L squared over B. Ito yung ikalawang formula ng resistance natin. So, gamitin naman natin ngayon itong B. I-substitute natin siya dito sa 1 para makuha natin yung third formula ng resistance. So, substitute B to 1. And then, R is equals to specific resistance. Multiply natin siya sa V over A over A, or also specific resistance times V over A. Multiply natin siya sa reciprocal nito, 1 over A. Magkakaroon tayo ngayon ng specific resistance times volume over A squared. Ito ang third formula ng ating resistance. Problem number 11. A coil has 6,000 turns of wire and a resistance of 380 ohms. So, ang N1 niya ay 6,000 turns. And ang resistance niya ay 380 ohms. So, the coil is rewound with the same quantity weight of wire but has 13,400 turns. How many ohms will the new coil have? So, ang hinahanap ay yung resistance 2. I-drawing ulit natin yung problem. So, sa unang Sa unang, ano niya, ang turns niya ay 6,000 lang. Tapos, nung nirewound siya, naging 13,400. Ang sabi sa problem, it has the same weight. So, we assume that volume 1 is equals to volume 2. And, take note na same material. So, ang specific resistance niya nung una ay equals din sa specific resistance nung ikalawa. I-assume din natin na ang length ay nung una ay equal lang din dun sa length ng ikalawa. So, ang pinagkaiba lang nila, yung length per turn. Kaya nabago yung turns number. So, pwedeng ang gamitin natin ng formula ng resistance dito ay specific resistance L squared over volume. So, masosolve natin yung problem using ratio and proportion. Then, we have R1 over R2 is equals to specific resistance 1 times length ng 1 over V1, squared over specific resistance 2 times length squared over V2. And then, sinabi kanina na ang specific resistance 1 is equals to specific resistance 2. V1 is also equal sa V2. So, makakancel lang to. Ang derivation naman ng ating length, usually sa mga problem, yan ay length per turn multiply natin sa number of turn. So, makakancel lang yan, kaya ang natitira ay yung length. So, ang gamitin natin ito dito. So, R1 over R2 is equals to length 1 times N1 squared over length 2 times N2 squared. So, from there, R1 over R2 is equals to L1 times N1 squared over L2 times N2 squared. So, L1 squared, N1 squared over L2 squared, N2 squared, R1 and R2. So, sinabi kanina na nirewound lang yung wire. So, i-assume din natin na yung length ng 1 ay equals lang dun sa second length. So, ito ay makakancel. Ang gagamitin nating formula ngayon ay R1 over R2 is equals to N1 squared over N2 squared. Ito na yung magiging formula natin para mahanap natin si R2. So, substitute lang natin R1, 380 over R2 na hinahanap natin is equals to N1 squared, 6,000 over 13,400 squared. Makukuha natin ang value ni R2 na 380 times 13,400 squared over 6,000 squared. So, ang value ng R2 natin ay 1,895.35 ohms. So, from the choices, ito ay letter A. A copper wire of unknown length has a resistance of 0.8 ohm. By successive passes through drawing dies, the length of the wire is increased to 2.5 times its original value. So, L2 is equals 2.5 times original value or yung L1. Assuming that resistivity remains unchanged, so specific resistivity 2 is equals to specific resistivity at 1. During the drawing process, determine the new value of resistance. So, binanggit dito sa problem na to na drawing process. Drawing is equals to drawn. Pag binanggit yan sa mga problem, ibig sabihin, yung wire recreated. Meaning, we may assume that it has the same volume. V2 is equals to V1. So, tips yon na pag binanggit sa problem na the wire is drawn or it has undergone drawing process, meaning the volume remains the same or remains constant. So, ano bang formula ng resistance natin ng may volume? Yung formula to natin na R is equals to specific resistance L squared over V. So, sinabi dito na remains unchanged ang specific resistivity. So, wala na yan. And then, ito nga, yung volume natin, recreated lang. So, ganun din. It remains constant. So, mangyayari, ang gagamitin nating formula, R is directly proportional to the square of the length. So, R1 over R2 is equals to L1 squared over L2 squared. Okay, so substitute lang natin yung mga values. So, R1 is 0.8, R2 ang unknown, ang L1 natin, yun yung original value, ang L2 natin ay 2.5 times L1 squared. So, 0.8 over R2 is equals to L1 squared over 2.5 squared times L1 squared. Cancel, cancel. So, na-cancel yung L1 squared natin. Makukuha na natin ngayon yung R2. So, R2 is equals to 0.8 ohms. Multiply natin sa 2.5 square. R2 will have the value 5 ohms. From the choices, 5 ohms is letter C. Problem number 13. A 1 meter rod of 2 cm diameter, length 1 natin ay 1 meter, and then diameter 1 natin ay 2 cm, is drawn until its resistance is 100 times the initial resistance. So, R2 is equals to 100 times the initial resistance or R1. The length afterward is length 2 ang hinahanap. So, binanggit ulit doon na ang wire natin ay drawn. So, we may assume that it has still the same volume. It is constant and same material, so it has the same resistivity. Kagaya nung ginagamit natin na formula dun sa number 12, yun din yung gagamitin natin dito para mahanap natin yung R2. I'm sorry, yung length 2. So, R1 is directly proportional to the square of length 1 over R2, which is also directly proportional to the square of length 2. So, initial resistance, ang R2 natin, 100 times the initial resistance is equals to length 1. Ano ba yung length 1 natin? 1 meter squared over L2 squared. Yun yung hinahanap natin. So, makakancel to. Then, we have L2 squared is equals to 1 meter squared multiply sa 100. And then, magkakaroon tayo ng 100 meter squared. So, L2 squared. So, L2 is equals to the square root of 100 meter squared. And then, makukuha natin si L2 na 10 meters. So, from the choices, it is letter A. A kilometer of wire having a diameter of 11.7 mm. So, ang length 1 natin ay 1 kilometer. Ang D1 natin ay 11.7 mm. And the resistance of 0.031 ohm. R1 natin ay 0.031 ohm. Is drawn so that its diameter is 5 mm. So, binanggit na naman yung term na drawn. Assume natin na ang volume 1 ay equal sa volume 2. Ang hinahanap ngayon ay yung resistance 2. So, makikita natin na dito sa given, associated ang D1 at D2. Saan ba associated ang mga diameter? Hindi ba sa area? Dun siya ginagamit. Pi over 4 D squared. So, anong formula ng resistance natin? Ang may A na may pi over 4 D squared at may volume. Ito yung third formula ng resistance natin na specific resistance times volume over A squared. So, pag isinubstitute natin kay A squared ito, R is equals to specific resistance times volume over pi over 4 D squared squared. So, makukuha natin na yung R ay specific resistance times volume over pi over 4 squared times D raised to 4. So, since ito ay constant din, magkakaroon tayo ng R na is equals to V over D raised to 4. Magiging ito yung equation natin. So, magiging formula ng resistance natin dito ay yung R. R is directly proportional to the volume but indirectly proportional to the D raised to 4. So, ito yung gagamitin natin. But, ginamit dun sa problem na ang wire ay drawn ulit. Drawn. So, meaning yung V1 ay equal sa V2. So, ang magiging formula natin dito, since ito ay constant, R is equals to the reciprocal of D raised to 4. So, magiging formula natin dyan, R1 is equals to D1 raised to 4. And yung R2 natin, magiging sa reciprocal naman ng 1 over D2 raised to 4. So, napupunta lang siya dito. Substitute natin dito yung mga given. Yung R1 natin ay 0.031. Ang R2 ang hinahanap. Ang D2 natin ay 5 mm raised to the fourth. And yung D1 natin ay 11.7 mm raised to the fourth. So, makukuha natin na yung R2 ay 0.031 times 11.7 raised to 4 over 5 raised to 4. So, magiging value ng R2 natin ay 0.93 ohms or letter C sa number 14. Problem number 15. A conductor whose diameter is 0.175 inch has a resistance of 0.5 ohm. The wire is drawn. So, drawn ulit. Assume natin na V1 is also equal sa V2 through a series of dies until its diameter is reduced to 0.08 inch. So, dito natin ay 0.08 inch. Assuming the specific resistance of the material remains constant, so specific resistance 1 is equal to specific resistance 2. What is the resistance of the lengthened conductor? So, R2 ang hinahanap. Kagaya lang to nung formula natin sa problem number 14. So, yun lang din yung gagamitin natin. R1 is directly proportional to the reciprocal of diameter 1 raised to 4. And yung R2, ganun din. So, pag inequate mo sila, magiging ganito. Substitute lang natin yung mga value. So, R1, 0.5 ohm. R2, yung hinahanap. D2 raised to 4, 0.08 inch raised to 4 over D1, 0.175 inch raised to 4. Makukuha natin na yung R2 ay 0.5 ohms times 0.175 raised to 4 inch raised to 4 over 0.8 raised to 4 inch raised to 4. Makakancel lang yan. And ang matitira natin na unit ay ohm. Ang value ng R2 natin ay 0.5 times 0.175 raised to 4 over 0.08 raised to 4. Magiging value ng R2 natin ay 11.45 ohms. So, sa choices, yan ay letter A.